Hi everyone, welcome back to my channel. So today we'll be going through another tutorial on the TI Inspire CX2 CAS calculator, and the topic today will be on simultaneous equations with the derivatives functions. So let's get started. So here we've got the curve with the equation y equals ax plus b over 2x minus 1, with stationary point at 2, 7. Find the values of a and b. So okay, so we want to, find the A and B given that we have a stationary point at 2, 7. So that means, so let's say this is f of x. So at f of 2 is equals to 7. So that's one of our equation. And the second equation is the derivative of x. So let's just call that gx. So derivative of x is equals to, at the point of x equals to 2, so f dash of 2 is equals to 0 because it's a stationary point. So the derivative of that x value is equal to 0. And then that would be equation 2. And then using these two equations, we can solve for a and b. Okay, so let's get started on the calculator. So what you want to do is, first of all, define f of x, and then define that as a times x plus, and then fraction b over 2 times x minus 1. So just plug that into your calculator here. You can see there. Yep. And then, so once that's defined, then the next thing is to define the derivative. So I can call it gx. So g of x, it's defined as, and then you go to calculus derivative. So go to this one here. So menu, calculus derivative, then press enter. So this should pop up like so. And then you just put d over dx, and then put fx here, and then just press enter like this. So that one's done. And then what you want to do is you want to go to algebra and then go to solve system of equation and select 1. So don't select 2, select 1 from this one. So algebra, solve system of equations here, press enter, and then select two equations and go for a comma b. So we're solving for variables a and b, and then just go okay. Okay, and then now two equations as we've mentioned was, so when x equals to 2, you get the y equals to 7, and the other one is the g of, in this case, when x is equal to 2, so when the derivative is 2, the gradient is basically 0. So you type that in and then press enter, and you get a equals to 2 and b equals to 9. Okay, so all right, so basically if we jump back to the workings here, so let me quickly share the screen here. Okay, so basically we've got our a and b. So in this case we've got y equals to 2x plus 9 over 2x minus 1. So that one is done. And for part B, it's coordinates of the other stationary point. So basically, there should be more than one stationary point. So we'll use the calculator to quickly find the other stationary point. All right, so let's jump back to our calculator. So once we've got our A and B, what we can do is we can lock that answer into our variable. So we can define A as 2, like this, and then press enter, and then we can lock B in. So that will be locked as 9, like this, and that's locked in. So that means like if you type g of x, which is the derivative functions, press enter, you can see the calculator automatically registers the a and b, and then now it's put into numbers. Whereas previously it was still defined as the algebra's a and b variables. So now we've got g of x in terms of like all the numbers. So what you want to do is you want to go to calculus, sorry, you want to go to algebra and solve, and you want to solve for g of x equals to 0. and then solving for x. So that way we can find all the x coordinates where the derivative is 0, because that's the question is asking for stationary points. So you can see the other point is actually at x equals to -1. So the question already gave to us that x equals to 2 was the other stationary point. So now that we know x equals to -1, so we just type f of -1 in to the calculator to get the y coordinate point of that. So the other stationary point is actually at x equals to -1 and y equals to -5. So let's quickly put that into our answers here. So you can see if we jump back here. Okay. So that means for part 2, part B here, the other coordinate points is just -1 and -5. And that's it. Using calculator to solve simultaneous equations, and then yeah, finding the other stationary points using calculator. So that's it for today. If you have any questions, feel free to comment down below. Otherwise, I'll see you in the next session. Okay, see you later.